Today we are going to see about the subject principles of software engineering. So in this we are going to see the second unit, that is requirement engineering. So in second unit we are going to see about the functional and non-functional requirement engineering process, feasibility studies, requirement elicitation and analysis, requirement validation, then modeling requirements such as data flow diagram, ER diagram, data dictionary, state transition diagram, and SRS document. So first we are going to see about requirement engineering. So requirement engineering is a process. So it is a process of finding out, analyzing, documenting, and checking the services and constraints for what? For developing a software. So this process is called as requirement engineering process. So in other words, it is a process of collecting the software requirements from the client and then understanding it, analyzing and documenting is called as requirement engineering. So there are, so according to IEEE, so the IEEE defines the software requirement as given below as a 2 points: a condition or capability needed by a user and a condition or capability that must be met or possessed by a system. So the condition and capability needed by the user are for what? To solve a problem or to achieve an objective. Next, a condition or a capability that must be met or possessed by a system to satisfy the standard and specifications or formally imposed documentation. So this put together, the requirement 1 and the 2 put together forms the software requirement process. So next is types of software requirements. So there are three classes of software requirements. One is domain requirement, another one is functional requirement, and the last one is non-functional requirements. So these are all the three classes of requirements. So normally requirement, software requirement is nothing but we are going to get the needs from the stakeholder, that is from the user or a customer who wants to build the software. So first requirement, here we are going to see about functional requirement. The functional requirement defines or describes what the system must do or what the system should do, or describes the functionality or the system service. For example, we can take a system, we are programming or we are developing a software for computing some values. Let us keep it as RMS value. So the functionality here is the computation of RMS value. So the system is doing the calculation to convert, that is to find out the RMS value. So here this is the functional requirement. So what are all the needs to compute the RMS value put together forms the functional requirement. So it heavily depends on the types of the software, expected user, and the types of systems where the software is used. So this is all about the functional requirement. So next is the example. So let us see the example for functional requirement. So the system shall allow the user to log in using a username and password. So here the login page or the application is allowing the user to getting into that page by getting the username and the password. So it is a functionality where it authenticates the user. Next, the application shall generate the monthly report. So here the application generates the monthly report is a functionality. Next, the system sends a notification after successful registration via email. So once the registration is over, what it does, it sends the successful notification to the customer once the registration process is over. So next is non-functional requirements. So the non-functional requirements, here it describes the system performance, that is its functionalities, describes the quality attributes of the system. So you can say, for example, I have dealt already with an RMS calculation software. So here in how many seconds the RMS value will be computed for the given input. So it is a kind of non-functional requirements. So it speaks about the speed of calculation of the RMS value. Likewise, you can take the performance, the speed, timeliness, and the accuracy. Everything comes under the non-functional requirements. For example, here let us consider the system responds to the user input within the 2 seconds. So here the time limit is 2 seconds. So it says about the non-functional requirements. So non-functional requirements are classified into mainly three types, that is product requirement, organization requirement, external requirement. So in product requirement you'll be having efficient, that is usability requirement, efficiency requirement, then dependability requirement, security requirement. Likewise you'll be having in organization environmental requirement, operational requirement, and you'll be having development requirement. In external requirements such as regulatory, ethical, legislative, these are all the non-functional requirement. So here the non-functional metrics such as reliability, availability, then security, maintainability, extendability, then portability, reusability, and resource utilization. So these are all the some of the non-functional requirement metrics. So let us say the example for the online banking system. So we can say now what will be the functional requirements and what will be the non-functional requirements and interface requirement. So for banking system, so functional requirement, we can say the login page. The system allows the user to log in with a username and password. It can be the functional requirements. So it allows the function of logging into the system or a particular page. Next, non-functional requirements, we can say the example in how many seconds the user or the form gets the input and it responds to the input. It may take 2 minutes or 2 seconds, like that we can say a non-functional requirement. Interface requirement. So the application sends an OTP. It is an online banking system. It can send an OTP via SMS. So here the SMS is a gateway or an interface for getting a notification. So these are all the examples for software specification. The software specification, normally you have three types. One is functional, non-functional, interface, or sometimes called as domain requirement. So here functional and non-functional requirements are very very important in this type. Next is domain requirement. So the domain requirements may be new functional or non-functional requirement constraints on existing requirements or define specific computation. So if domain requirements are not satisfied, the systems may not be workable or it is unworkable. So this is about domain requirement. So it imposes the domain requirements on the system. So there are two main problems with domain requirement. One is understandability, another one is implicitness. So these are all the two problems in domain requirements. So this is all about the difference between the functional and non-functional requirements. The functional requirements are mandatory requirements, whereas non-functional may not be required. It is non-mandatory. So it helps to understand the functionality of the system. It helps to understand the system performance. It is easy to define and it is hard to define. Likewise, this is the comparison between the functional and non-functional requirements. Next is requirement engineering task. So there are 7 tasks for the requirement engineering process. One is inception, elicitation, elaboration, negotiation, specification, validation, and management. So the first phase is inception. So inception is the task. So it is a task where you can where the task is to check or ask a set of question to establish the software process. So we have to ask the set of question in inception so that we can come to a need what the customer requires. So based on the questions, what we can do, we can understand the basic details, aim and goal of a project, identify the stakeholders and who want the solution, what is the nature of the solution, like that we can have in inception. Next is elicitation. So this phase focus on gathering the requirement from the stakeholder. So inception will be asking the question and getting something. So here in elicitation we will be gathering the things. So here the right people must be involved in this phase in order to get the requirements correctly. So here there will be some problems occurs during elicitation. The problems such as problem of scope, problem of understandability, and problem of volatility is the problems which occurs during elicitation. Next is elaboration. So it takes the requirements have been gathered. So in first two phases what we have gathered from inception and elicitation phase and elaborate it or expand it. So they will be saying in one word what they want, it will be elaborated in the elaboration phase. Next is negotiation. In elaboration phase we will be consolidating the requirements from first and second phase, that is elaboration. Next, negotiation. So negotiation is between the developer and the customer. So between the developer and customer you will be having a negotiation about the limited availability of resources, delivery time, product cost or project cost, and overall estimation of the project is done. They will be having a negotiation about those things. So that is about negotiation. Next is specification. So in this task the requirement engineer construct a final work product. So what the customer actually wants, it will be required, it will be specified in this. It collects the all user, system, functional and non-functional requirements from the user, and it will be listed in the form of a documentation like SRS or design document recommendation. Next is validation. So here in validation we'll be checking the errors and debugging it. Finally the product works or not, we'll be validating. So while we are validating we have to consider the SRS document to meet out whether the customer needs are satisfied or not. In management, so it is a part of identifying, controlling, tracking and establishing the requirements for the successful and smooth implementation of the project. So this is all about requirement management. So the requirement task, it is a sequential flow. So it starts from elicitation, that is inception, elicitation, elaboration, negotiation, specification, then validation, at last requirement management. The summary of this task is in inception we will be having better understanding, elicitation will be having clear understanding of the requirement, in elaboration we will be refining the model, refining and modeling, negotiation we will be settling and conflicts, in specification you will be having the SRS documents, validation will be validating the requirement, and finally in management managing the changes required. Next is requirement engineering process. So as we seen, it is a structured approach for what to manage the requirement of the system need or a software need. It is done by identifying, analysis and validating and finally documenting and managing the requirements of the software. So there are 5 distinct phases in requirement engineering. First is requirement elicitation, requirement analysis and negotiation, requirement specification, requirement validation and management. So this is about the requirement engineering process. First we will be doing the feasibility study, that is possibilities, what are all the viabilities that avails in the development of the system. Then from that you will be getting the feasibility report. Then from the based on the feasibility report you will be going for requirement elicitation and analysis. From requirement elicitation and analysis you will be having the system model. Then you will be having the requirement specification. From the requirement specifications you will be validating those requirements by making it a document based on the system and user requirements. At last you will be managing all this. So this is about requirement engineering process. So feasibility study. So it is the first phase of requirement engineering process. So feasibility is the aim and goal of the customer and organization behind the implementation of the software. What is the aim and goal? So this is about the feasibility. So there are different types of feasibilities. Few of them are listed here. First one is technical feasibility. So it evaluates the current technology, that is technical feasibility. Next is operational feasibility. Next, economical feasibility, legal feasibility and schedule feasibility. Next, requirement analysis and negotiation. So in requirement analysis and negotiation, we will be gathering all the actual requirements and about the needs and expectation of the stakeholders of the software system will be collected and gathered. So this is about requirement elicitation process, requirement elicitation analysis process. First we will be having the requirement entry process is here. So domain understanding, you'll be having the domain understanding. From the domain understanding, you'll be having the requirement collection. Once the requirement is collected, it will be classified. Once it is classified, you'll be having the conflict resolution. Based on the conflicts, you'll be prioritizing. Prioritization is done. Then once the prioritization is done, you will be validating the requirements. At last, you will be having the requirement definition and specification. So there are different requirement elicitation methods. First is interviews, brainstorming session, fast, DFD, and viewpoints and use cases. So in an interview, what you will be doing, you will be asking or conducting the interviews to understand the customer expectation for the software. It will be imposed on the stakeholders. The questions will be imposed on the stakeholders. It is impossible to interview every stakeholders, so we have to identify the stakeholders correctly and we to have a interview session. It is a kind of requirement gathering. So it is in structured interview, you will be having an agenda of having open questions. The questions will be prepared, it will be given to the customer or the stakeholder. They will be answering for the question. Based on the questions answered, you will be collecting the requirements needed by the customer. Next is brainstorming session. So it is a group technique. So it is used to generate lot of new ideas in brainstorming session. So it is a platform to share their views. So every idea is documented in brainstorming session so that everyone can see it. Finally, a document is prepared which consists of list of requirements imposed by the customer and it is prioritized. Next is fast. It is facilitated application specification techniques. So here this objective is to bridge the gap between the expectation gap between the developers thinking and they are supposed to build what the customer thinks they are going to get. So it is a team oriented approach. So here what they will do in team oriented approach is developed for requirement gathering. It is a kind of requirement gathering techniques. So it will be bridging the gap between the expectation of the customer and the developer. Next is QFD. So it is a technique, quality function deployment. So customer satisfaction is a prime concern here. So normally three requirements is identified here. Normal requirement, expected requirement, and excited requirement will be identified in QFD. Next is viewpoint. So in viewpoint, the way of structuring the requirements to represent the customer or the stakeholders perspective. So the stakeholders may be classified under different viewpoints. So there are basically three types of viewpoints are there. One is interactive viewpointers or indirect, then domain viewpoint. So the customer views will be based on this as a hierarchy. Next is use case. So here identifying the individual interaction and the use case is used extensively to represent the requirements, or we can do requirement elicitation. Next is requirement specification. So normally requirement specification will be written in natural language. So after collecting them, you have to document it in a technical language. So the model used in the stages include ER diagram, DFT diagram, then functional decomposition diagram, data dictionary, etc. Next is requirement monitoring. So in requirement monitoring, there are 5 steps or 5 tasks: distributed debugging, runtime verification, runtime validation, business activity monitoring, evaluation, and code design. So these are the 5 tasks which are involved in requirement monitoring process. So in distributed debugging, the errors are found out and their causes are determined. So runtime verification, we can see whether the software matches the specification. In runtime validation, we can assess whether the evolving software meets the customer goal. In document activity monitoring, evaluates whether the system specifies the business goal. And evaluation and code design provides the information to the stakeholder as a system involves. Next is requirement validation. So in requirement validation, it is a process of determining the specifications is consistent with the requirement definition. That is, make sure that the requirement meets with the customer. So in requirement validation, we are ensuring that all the system requirements have been stated that are inconsistent, omissions and error has been detected and corrected. The work product conform to the standards and established for the process and the product. So this is about requirement validation. Requirement validation techniques, there will be different requirement validation techniques. One is manual techniques, next one is automated techniques. In manual techniques, we will be reading and checking and manually cross-referring interviews, reviews, checklists. Likewise, so these are all the different techniques in manual techniques. In automated techniques, you will be having automated cross-reference, automated models to extract the function prototypes, etc. So next is requirement reviews. So review is a manual process. So where the client and the contractor will be sitting and discussing about the document, about the anomalies and the omissions occurs in the requirement engineering process. So the review team will sit and check whether the requirements are completely and consistent. The reviews includes verification, comprehensibility and traceability. At last, requirement management. So as we seen earlier, requirement management is the analyzing, documentation, tracking, then prioritizing and agreeing on the requirements and controlling the communication with relevant stakeholders. So at last, you will be having the SRS and we will be seeing the whether the requirements are gathered in this phase. So this is about requirement management. So the tools required for requirement management are observation report, questionnaires, use cases, user stories, requirement workshop, mind mapping, role playing and prototyping. So these are all the tools required in or involved in requirement engineering. Next is element of requirement models. So there are different requirement analysis model. One is scenario based model, class based model, flow oriented model, another one is behavior model. So in a scenario based model, you will be having use case diagram. In flow oriented, you will be having DFD diagram. In behavioral model, you will be having sequence diagram. In class based model, you will be having the class diagram in order to have the requirement analysis model. So scenario based, it is for developing and designing the model. It is important for software engineers to understand how end users and other actors want to interact with the system. So here in scenario based model, you'll be having use case diagram. So in use case diagram, there are three elements. One is actors, use case and system boundary. So actors are the users of the system. Use cases are the functionalities provided or the service provided on the system. And the system boundary, which is the limit or the scope of the system where we are modeling. So boundary, it is normally represented in rectangular shape. Use case is in oval shape, and the actor, this is there is an relationship that is included an extend relationship. So here it is a student management system. Here the actors are student and the teacher, and the use cases are check attendance, check timetable, check grades, update attendance and update grade. So here student can access these three models, which are the models check the attendance, check timetable and check grades. Here teacher is an actor who can access all the modules, and here it is the system boundary. So this rectangular shape indicates the system boundary, that is the system management system. So this is about use case diagram. Next is activity diagram. So this diagram helps in predicting the workflow from one activity to the another activity. So initial state will be filled circle, action box will be having blended rectangle, then decision box, and final state will be double circle. So this is about activity diagram. Next, class based diagram. So class based modeling or an element. So here class model represent the class, objects, attributes and operations of a system. So this is a class. Here the class name is customer. The members of the classes are name and location. The member functions are send order and receive order. So this is generalization relation. It is a superclass and it is a subclass. So the superclass as an order is the order. Here the subclass is special order and normal order. So this subclass can access the properties of superclass. Here also we are having another diagram. So here the classes are withdraw, admin, employee, bank user, credit, debit and transaction. So here it is of, this is the superclass and this is the base class. So this is the superclass and this is the subclasses. Next is flow oriented model. So it shows the transformation of the process that occurs in the functions. So here DFT diagram. So data flow diagram is a graphical representation of flow of data in any system. So in the incoming data flow and outgoing data flow and the stored data are depicted in the data flow diagram. So normally this is an entity and this is process and this is data store and this is data flow. So DFT is a graphical representation of data flow in a software system. The first step is to create an overview of the system. So components of data flow are, first is entity, which is represented in rectangular shape. So normally the entity will be named. It must be named and no direction flows between two entities. Next is circle or bubble, represent the process or transformation that is applied to the data. So here ticket booking, it is a circle or a transformation or a function or a process. So here it is named as ticket booking. So this label must not be repeated in a diagram. So it must be properly labeled. Then components of data flow. So this is the user login is a process. So here you should not have flow like this in between. So if you are having like this, it is called as joins and this is called as fork. So next, the component data source. So this is the symbol for data source, opened rectangle. So user information and order information, this is about data store. General rules. So no process may have only the output like this. It must not have only the output called as miracle. No process must have only the input that is called as black hole as shown in the figure. Data cannot be moved directly from one data store to another without any process. So data cannot move from an external entity to the data store without any central process. Because the data cannot be shrink, that is in one input direction, or source, that is from one output direction. Likewise, it must not be there. This is the general rules. So there are different levels of DFT. First one is level 0 DFT. So here you will be having only one process. So process must be only one and you will be having different entities. For example, here the process is registration process and you will be having different entities such as faculty, registrar and students. Level 1. So if you are having more than 5 to 9 process or more than one process, it is called as level 1 DFT. So let us consider here we are having two process. One is enroll student, another one is compile and distribute information, and we are having different entities. So that's level 1 DFT. So level 2 DFT. So level 2 DFT, it must expand the level 1. So 1.1. So what is present in 1? One is student enrollment. This student enrollment will be expanded. That is deepest of level 1. So student enrollment will be expanded as obtain student preference, check eligibility and enroll students in class. So normally in level 1 it is set as student enroll students. This is expanded as 1.1, 1.2 and 1.3. Though in level, this is about level 2. In level 3, this particular module will be again elaborated. So let us consider an example for an ATM system. So here ATM customer, bank and operator are the entities and ATM system is a process here. So that is level 0 and this is level 1. You are having three processes. One is interface with the customer, ATM control ATM, interface with bank and interface with operator. And you are having different entities and different data stores. This is level 2 DFT. So here the third interface with operator is expanded, such as process operator input, update ATM cache database and display messages. Next is ER model, entity relationship model. So in this entity relationship model, we are having different components, that is entity, attributes and relationship. So entity is represented in a rectangular way. Entity is an object or a thing such as person, place, etc. So entity must have a set of properties. It is represented in rectangular box. Next, attributes. So attributes, it is represented in ellipse. So properties of entity is known as attributes. So here the entity is student. So the students attributes are register number, date of birth and name. Next is relationship. So the relationship is defined as an association between the entities. So from one entity to another entity, how the relationships are. One to one, one to many, many to one, many to many. These are the relationship between the entities. So here, student entity and register number is also another. You can have one to one relationship between the entities. So here staff and student. So here one to many entities. So here one staff may have different students in teaching process. So this is the relationship is here as teaching. So many students, one department. Many students joins one department. So here many students join is a relation. Department is an entity. So many students, many department. So many games. So many students have many games, can play many games. So likewise we'll be having different relationship. So ER diagram. So rectangle represent the entity, ellipse represent the attributes and diamond represent the relationship. So underline to represent the primary key. So it is an example for library management. So here the entities are member, book, publisher. So here the relationship is between the book and publisher is published by, member and books are borrowed. So these are all the attributes. The member has a register number, member ID, department and year, and book has book ID, text, author, so title, author, price and expiry date. Next, publisher has the publisher ID, publisher name and address. So this ellipse represent the attributes. Next is data dictionary. So data dictionary is nothing but data about the data. So this dictionary has the data which contains information about the data. So an organized collection of all data elements of a system with precise and rigorous definition so that the user and the system analyst will have the common understanding about input output components of store and intermediate calculations. So this is about data dictionary. So here we are having a data dictionary which has the name. This name field has a description of name of an item. Aliases is nothing but other name of the data item. Description field expands the description. It is a notation for the goal or a context. Related data items, range of values, data structure definition. So these are all the information about the data. So this is description about the data. So this is notation for data dictionary. Next is state transition diagram. So this is the symbol for state transition diagram. Normally a state transition diagram is a graphical representation of how a system or an object state changes over a time in a response to an event. So to an event, how an object responds to an event. So here this is initial state, final state. So this is a simple state and this is composite state. So here we can have an ATM system. So here, so this is a state. So this is initial state and this is the final state. So reading a card, once the card is readed, you have to read the PIN. Then you have to choose the transaction. Then based on the transaction, you have to perform the transaction. Then again, once the transaction is finished, you have to eject the card and you have to stop the process. It is a kind of state transition. Next is SRS. So SRS is nothing but, so this is the last topic of unit 2. So SRS is nothing but software requirement specification. So this SRS, it helps, it contains the document of the requirements which are specified by the customer in a precise and an elaborated way. It also has the behavior of the system, functional, non-functional requirements of the system. Everything will be put and it will be signed off at the end of requirement engineering phase by both the customer and the developer. The user of an SRS, who will use the SRS document? The client will use the SRS for seeing the requirements specified by them, then the development team, maintenance team and the technical writer. So these are all the inputs for them. This SRS is the input for these teams. So what is the need for SRS document? So it is a structure and formalities, formulas of all project requirements. It helps the development team build a product exactly and correctly, not to meet the requirements of the customer. So it provides all team members with the necessary information while working on a project. So it minimizes the possibilities of misunderstanding. So it defines the scope of the work and also it estimates the requirement development budgets. So structure of an SRS. So normally the structure will be, it is an example. It may have introduction. In the introduction, you'll be having the purpose, intended audience, scope, definition, and reference. Then overall description, you'll be having the user interface, system interface, hardware requirement, constraints, user status, characteristics, system features and requirements. You'll be having the functional requirements, non-functional requirements, then domain requirements, database, external interface. You'll be having diagrammatic representation, then deliver for approval. So characteristics of a good SRS. So and good SRS must be correct, it must be complete, it must be consistent, it must be unambiguous, and it must be modifiable, and it must be ranking of importance and stabilities. That is, it must be prioritized. All the requirement must be prioritized in SRS. Then it must be verifiable, it must be traceable. So it must have a good independency and testability. Understand it must be easily understood by the customer. The level of abstraction should be explained, and it must be explicitly defined by the developer and the customer. So this is about SRS. Thank you. About the second unit.